Hey guys, I'm just gonna run through some examples from the second part of section 1 in chapter 5. So just do some more antiderivatives, indefinite integrals, and I'll have you guys try a couple of then the homeworks at the end. So let's do it. Right. So rewrite the problem so that it's manageable. 1 over x to the third. We have a quotient, 1 and x to the third. But the only way to integrate something so far that we have is like our trig integration and our power rule. So if I have x to the n, the antiderivative is x to the n plus 1 over n plus 1 plus some constant. So if I can get something to look like x to the n, I'll be all set. Let's see. By the way, this also only applies if n is not -1. We'll see why in a second. So 1 over x to the third, that's really the same thing as x to the -3 dx. Writing it like that helps because now I have the power rule I can use if I just need to take my exponent and add 1 to it. -3 plus 1 is -2, so it's going to be x to the -2 over -2 plus some constant c. Simplifying that, I have a negative in the exponent. I can bring it down to the denominator, make that a positive x squared, and we get that -2 on the bottom plus c. This one, to rewrite it, let's just call it the square root of x is really just x to the 1/2. I rewrote it as terms as x to the n, so it looks like my power rule can be used. Just add 1 plus a half is 3/2, so it's going to be x to the 3/2 over 3/2 plus some constant. And then when you're dividing by 3/2, that's the same thing as multiplying by the reciprocal. That's 2/3 x to the 3/2 plus c. You can think of that as keep, change, flip, or just knowing that dividing by 3/2 is the same thing as multiplying by 2/3, the reciprocal. The book for simplifying part C, they just factor out the 2. The 2 is a constant. You can always factor out a constant. You don't actually need to do this in this one, but this is what they suggested to do. The antiderivative of sine is negative cosine, right? The derivative of negative cosine would be positive sine, so the antiderivative of sine would be negative cosine. You just got to kind of think backwards. So it's going to be 2 times negative cosine x plus c, and 2 times negative cosine x is just -2 cosine x plus some constant. And part D is the one where it gets a little tricky. If you want to factor out the 3, no issues there. Then I just get 1 over x dx. But what you can do, but it's not going to help here, is if you wanted to say, well, can I just rewrite this as x to the -1 dx? I'd say, sure, you can. But if you use the power rule here, you get, let's see, add 1 to -1, you get 0. So it's x to the 0 over 0 plus c. Remember, you can't divide by 0. That would be undefined, and this only works for when n does not equal -1. The antiderivative when x does equal -1 in this case is just going to be the antiderivative of 1 over x is the natural log of the absolute value of x plus c. And that's just something you have to remember. If you go backwards, what was the derivative of natural log? The derivative of natural log was 1 over x. So the antiderivative of 1 over x is the natural log. You just got to remember the absolute value of x in there. There's nothing to simplify, so that's it. The point of these 4 problems is just saying we can rewrite these as something we've seen before and just use the power rule. If it's trig, just use your trig rules and just knowing 1 over x, the antiderivative, that's natural log of x. All right, this one's going to be the same idea. Can we write this in a simpler way? I have kind of like the function x plus 1 divided by the function the square root of x, and we don't have a nice quotient antiderivative rule, so I need to rewrite this. Let me just rewrite the square root of x as x to the 1/2. That's okay. And then I'm going to break this up. I'm going to distribute the x to the 1/2. So both pieces in the numerator, I can divide by x to the 1/2. So x over x to the 1/2 plus 1 over x to the 1/2 is fine. Now we just got to simplify. When I have a power divided by, when I'm dividing two numbers with the same base, I can just subtract the exponents. So 1 minus a half is a half. So that's just x to the 1/2. 1 over x to the 1/2 I can rewrite as x to the negative 1/2. The goal of that, again, is so I can use my power rule for antiderivatives. Just add 1 to 1/2, and I'm going to get 3/2, which we just did a second ago. Add 1 to negative 1/2, you get positive 1/2. So I'm going to have x to the 1/2 over 1/2 plus some constant. And just simplify this. Rewrite 3/2 as times 2, dividing by 3/2 as times 2/3. So we're going to really just get our final answer of 2/3 x to the 3/2 plus 2 x to the 1/2 plus c. Again, dividing by a half is the same thing as multiplying by 2. Just multiply by the reciprocal, it's the same thing. And we got our answer. So again, taking a tougher problem there and just rewriting it into powers, we can use our power rule, no problem. This one can get a little tricky. Sine over cosine, that's not a rule, and I can't just take the integral of the top and bottom and say that's my answer. We have a quotient. I'm going to see if I can rewrite this to something that looks a little bit more familiar. Cosine x is really cosine squared x is just cosine times cosine. So let's just rewrite it like that. Sine over cosine we know is tangent, and 1 over cosine is secant. Now that feels like it's not helpful, but I think tangent x times secant x, the antiderivative of that is in our chart. Let's see, in the book, we had that here. There it is, right? The antiderivative of secant u tangent u is just secant u. If you remember back with derivatives, the derivative of secant was secant tangent. And we're just kind of working backwards from that. The derivative of secant was secant tangent. And so the antiderivative of secant tangent is just going to be secant plus some constant, of course. I'm not expecting you to memorize that the antiderivative of tangent x, secant x is secant x, but just knowing that you can look that particular one up. So if you see a problem like this, that's a strategy that you could go for. Here's not a bad time. Pause the video, copy these down, see if you can do them on your own. I'm going to do them now, and let's see if you got the answer that I got. The first one, rewrite that as 2x to the negative 1/2 dx, right? Because that's x to the 1/2, and bring it up to the numerator, it becomes x to the negative 1/2. And then we just got to use our power rule. It's going to be 2x, negative 1/2 plus 1 is positive 1/2 divided by 1/2 plus c. And then when you're dividing by a half, that's the same thing as multiplying by 2. And 2 times that 2 on the top is going to give me 4x to the 1/2 plus c. Okay. Moving on, we have this antiderivative, t squared plus 1 squared. Let's just FOIL that. That's going to be t to the 4th plus 2t squared plus 1 dt. And if I were to take the antiderivative of that, no problem. That's just going to be t to the 5th over 5, just adding 1 to the 4. This is going to be 2t to the 3rd over 3, just adding 1 to the 2. The antiderivative of 1 is going to be 1t, or just t, plus some constant. You don't really need to simplify that anymore, but a lot of times, instead of writing t to the 5th over 5, I would just write 1/5 t to the 5th. And then the other one, I would just write 2/3 t to the 3rd plus t plus c. So that's fine. Next one, again, distribute the denominator. This is really x cubed over x squared plus 3 over x squared, which would simplify to x, right? these two are going to cancel out 2 of those, and I have 1 left over. 3 over x squared is the same thing as 3x to the negative 2. And the antiderivative of x is going to be, let's see, this is x to the first, so you're just going to add 1 to that, and you get x squared over 2. The antiderivative of 3x to the negative 2, let's see, that's going to be 3x to the negative 1 over negative 1, plus some constant, so we get 1/2 x squared first. We have a negative 3 over x second, plus some constant. I just took this x to the negative 1 and put it to the denominator and made that x to the positive 1 on the bottom. This one, first things first, this is really x to the 1/3. So if I distribute that x to the 1/3 in, I'm going to have, let's see, 1/3 plus 1 is 4/3. That's going to be x to the 4/3, right? 3/3 plus 1/3, yeah. Minus 4 x to the 1/3 dx. Again, I didn't do any calculus. I didn't do any anti-differentiation there. I just did some algebra to rewrite it. Now here's where the calculus comes in. If I take x to the 4/3, now I can use the power rule. 4/3 plus 1 is 7/3. So x to the 7/3 over 7/3. This next one is going to be minus 4x to the 1/3 plus 1 is 4/3 over 4/3, plus some constant. Again, keep, change, flip, or whatever. Dividing by 7/3 is really just multiplying by 3/7. Dividing by 4/3 is the same thing as multiplying by 3/4. Plus some constant. These 4s are going to cancel out, so it's really just 3/7 x to the 7/3 minus 3x to the 4/3 plus some constant. And that's it. So if you got those answers correct, great. If not, again, feel free to email me. The homework is going to be page 291, numbers 1 through 4, 15 through 39, odds 40, 49, 50, 63 through 68. If you have any questions on the homework, email me. Right now, the plan is to just do it on a scrap piece of paper, take a picture of it, send it to me. I'm going to try to post a picture of the homework pages so that you can see it there. Anyways, that's it.